Okay. So, today this is section 5.3. I want you to turn to the back side of the graph paper that's blank right now and write 5.3 scatter plots. Today is 119. I want you to draw for me three graphs. They're just sketches. We're making that first quadrant really big because we're going to be graphing positive data. So they kind of look like L's. Make sure you mark X and Y on each one. Anybody know what a scatter plot is? I assume you've seen them before in science or made them before?
They're like dots, like
Yep.
data.
Yes, a whole bunch of dots with data. And you do not connect the dots. So these are just going to be a whole bunch of by themselves dots. Why do we make scatter plots in real life, not just in math class? Because in math class the answer is because I told you to. But how about in real life? When would you make a scatter plot?
To show like graph where like the data was that you got.
To display data to somebody else, that's for sure.
Find the average.
Not, well, you could find the average. You could find a line of fit, which would kind of predict what future things would be. People often use scatter plots for that. Go ahead.
In my old science class, we would do it for like, so like one of our assignments was it was like year by year. It wasn't like over the months. It was just year by year.
Mm-hmm. So you can kind of see trends.
Yeah.
So scatter plots are usually used. I'm going to write it down here. Scatter plots are used to see a relationship between two variables. Got some Play-Doh with your guys' name on them. So, there are three different possibilities. One is called a positive correlation. Correlation. One is called a negative correlation. And one is called no correlation. A positive correlation looks like this. The dots are kind of going upward, left to right, like a positive slope. And it's okay if you have a couple dots that don't follow the trend, that look weird. Can anybody think of, for a prize, grab my calculator, a real life situation where you'd have two things that have a positive correlation with each other, which means as one goes up, the other goes up. hiding behind my computer. Anybody think of a situation where as one thing goes up, the other thing goes up? Cameron, go ahead.
So like the inflation of things, so like if one thing and like the price of one thing inflates, the rest of something might inflate.
Yeah, so as inflation happens, so, all right, I'm gonna write that one down here. As inflation happens, inflation goes up, then the cost of things goes up. That makes sense to me. Go grab a I'm a winner sign or a Play-Doh. How about negative correlation? What does that look like?
Both to go down.
Downhill. Remember, it doesn't have to be perfectly in a line. Just has to trend down. Maybe you got a couple spots that are kind of out, but most of them are going downhill. Can anybody for a prize think of something here? Now, I'm going to write it over here. Everybody look up. As one goes up, the other goes down. As one thing goes up, the other thing goes down. That's a hard one.
There could be some, like, sometimes when things get more expensive, then people don't buy them as much.
Yes, that is exactly right. So as things get more expensive, nice answer. If things get more expensive, how much people buy goes down. That's a great answer. Another simple answer could be the higher the temperature gets outside, the less clothing you're probably going to wear. All right, go get a prize, Macy. How about no correlation? Anybody know what that one is? Looks like? Not flat. That actually still has a correlation.
Random.
Yes, random. So like kind of there's dots all over the place. No correlation means there's just no relationship between the two variables. Can anybody think of an example for me where there's no relationship between two things? One thing does not affect the other at all? Are we going to let Cameron have it again? Or are you just stretching? Somebody tell me something that has no correlation between two things that don't affect each other at all.
Two things that don't affect each other at all.
Callie? Changed your mind? Tristan?
The cost of toilet paper and my baby's dog.
Cost of toilet paper and how much your dog weighs?
Yeah.
Okay, how much your Tristan's dog weighs? I really hope that as toilet paper prices go up, that your dog doesn't get heavier, or opposite. Your dog's like, wait, how much does toilet paper cost? I cannot eat anything today. I'm so disgusted. And by the way, there's a difference between correlation and causation. Correlation implies that two things are related, right? Like this. Causation means one caused the other to happen. For example, if I said to you, I bet you the more like rain boots that people wear, the more umbrellas they have with them.
There's less one, can you move it down? There's less.
So I bet you as the more people I see that have rain boots on outside, the more umbrellas I'll see. Does that make sense to you guys? They're both correlated.
Yes.
Did rain boots cause umbrellas?
No.
No. Did umbrellas cause rain boots? No. What caused both of them?
Rain.
Rain. So they are definitely correlated, but they're not caused by one another. There's also some random things, like there's one that was like, it was the number of, it's like the global temperatures, keep rising a little bit. And it was like a graph of global temperatures and a graph of the number of pirates in the world. And they are going up almost exactly the same. And nothing to do with each other. Sometimes it is just coincidence. If you think about enough things in real life, there's lots of things that are just coincidence. All right, so flip over to the other side, and we're going to be doing our homework together. Our homework is we're going to make a scatter plot out of the data that I got earlier. So I'm going to help you set up your graph. This is going to be due on Monday, but you might be able to get it done just before the end of class. So everybody take your graph, and let's do it like this, like horizontal in front of you. What do we call that? The hot dog way?